Welcome, this is Professor Ridge, and today's lesson 2.3 Models and Applications. Let's start with the first learning objective: set up a linear equation to solve a real-world application, aka word problems. Okay, I'd just like to go over Table 1 from the text. So when dealing with real-world applications, there's certain expressions that we can translate directly into math. Okay, so this lists some of the common verbal expressions and their equivalent mathematical expressions. So one number exceeds another by a. So when you exceed by a, you're going to set a variable for a number. So it'd be x, y, whatever, and then it exceeds another by a. So you're going to do plus a. So x plus a. Twice a number simply means 2 times a number, so 2x. One number is a more than another number. Oh, it's a more than. So the quantity a. So one number is a more than another number. So basically the same as the first one. You're just going to add a. So here's a number. This number exceeds this one by a. One number is a less than twice another number. So if you have a number x, twice a number and then minus a, okay, is a less than twice another number. The product of a number a decreased by b. Oh, let me read that again. The product of a number and a. So whenever you see this structure, that's where so the product, I always tell my students this, is when you have the product and then the word and, that's going to be where this symbol for the product, and then see we have the quotient, and then we have this, that's where divided by. So the product of a number, so that could be x and a, so a times x, decreased by, so that's subtracting b. The quotient of a number and the number plus a is, okay, that's going to be our equals. Okay, so the quotient is divided by, so we're going to put a divided by there. So we're going to have a number on top, x, and that's the divided by, the fraction bar. The number, which is x, plus a, so that's on the bottom, is your equals 3 times the number, so 3 times x. The product of 3 times a number, so again, here's that word product. So we're going to have, we're going to look for and then we're going to have 2 numbers. So 3 times a number, so that would be 3x. And, so that's the times. Okay, there's no dot there, but, you know, that's what 3x with the parentheses means, times. The number decreased by b, so x minus b, is, so that's your equals, c. Okay, so how to. Given a real-world problem, model a linear equation to fit it. So think of this as your guideline. You know, this is typically how you would approach it. So first step, identify the known quantities. Okay, this is key here. Assign a variable to represent the unknown quantities. And you want to write this stuff down usually. 3, if there's more than one unknown quantity, find a way to write the second unknown in terms of the first. So that way you don't have to use 2 equations with 2 variables. And then 4, writing an equation interpreting the words as the mathematical operations. And then 5, solve the equation. Be sure the solution can be explained in words, including the units of measure. Let's look at example 1. Find a linear equation to solve the following unknown quantities. One number exceeds another number by 17, and their sum is 31. Find the 2 numbers. Okay, so our first step, then we want to identify the known quantities. Well, we got this. We got one number exceeds 1 by 17. There's sum, so we know the sum is 31. Okay, and if we're going to, let's label, say, the first number, we'll call that x, and then the second number, now we could use y, but then we're going to have to set up two equations, two variables. But remember, the suggestion was if there's more than one unknown quantity, find a way to write the second unknown in terms of the first. So they gave us the phrase right here, one number exceeds another number by 17. So the other number is going to exceed the first one by 17. Okay, and then the sum, so how do you find the sum of these two numbers? You just add them together. So x, that's the first number. The second number exceeds the first one by 17. So we got the first number, the second number. We don't need the parentheses, I just want to emphasize those are the two numbers. And the sum is 31. Okay, now we're going to solve this equation. So you can drop the parentheses, and then you're going to combine like terms. X plus x is 2x. Okay, we want to get all the variables on one side, it is. All the constants on the other. So we're going to subtract 17 from both sides. So the 17's cancel. 31 minus 17 is 14. And then we want to get x by itself, so divide by the 2. And golden rule, which do one side, do the other. So we're dividing both sides by 2. So then x must be 14 divided by 2 is 7. Okay, now we want to answer the question. I said find the two numbers. So x is the first number, which is 7. The other one, 7 plus 17, which is 24. And you can see that sum is 31. So the two numbers are 7 and 17. And there we go. All right, looking at example 2, setting up a linear equation solver application. All right, there are two cell phone companies that offer different packages. Company A charges a monthly service fee of $34 plus 5 cents or $0.05 per minute for talk time. Company B charges a monthly service fee of $40 plus a 4 cents per minute or $0.04 per minute. Okay, write a linear equation that models the packages offered by both companies. All right, let's start with the A there. Okay, so let's see. Write a linear equation that models packages offered by both companies. So Company A charges, let's see, we'll call A the cost. Okay, so A is equal to, we got a $34 monthly flat fee plus 0.05, and we'll say X, for the X is the number of minutes. So we should probably write that down somewhere. X is the number of minutes. Of talk time. Okay, so that's the cost for A, and then for Company B, we'll call B their costs. Okay, so same thing. So that's going to be the flat rate of $40 per month plus your 4 cents or $0.04 per minute times the number of minutes you talk. All right, on to B. If the average number of minutes used each month is 1160 or 1,160 minutes, which company offers the better plan? Okay, so we're saying if X is 1160, so you're going to say A, cost for company A is going to be $34 plus 0.05 times 1160, and then we just punch this in our calculator and we get $92. All right, so B, if same thing, if X is 1160, we get B, the cost, is going to be 40 plus 0.04x. Oh, we're going to take X out, substitute in 1160, punch that in our calculator, and we get 86.4. So $86.40. So you can see company B would be the cheaper one to answer that one. All right, moving on to C. If the average number of minutes used each month is 420, which one offers a better plan? Let me just move this up. Okay, so we'll do C. So if X is 420, 420, A is going to be equal to 34 plus 0.05 times 420, which is going to be, okay, so that works out to $55. Okay, and then this one, if X is 420, I did it again. B, so again, that's the cost for company B, will be the $40 flat fee plus 4 cents per minute, 420 minutes. Punch that in the calculator, and we get 56.8. So $56.80. So in this case, company A would be cheaper. So how many, on to D. How many minutes of talk time will yield equal payments from both? So what we want to know is, when is the cost of A going to be equal to the cost of B? And so we know that the cost of A is 34 plus 0.05 x, and the cost of B is 40 plus 0.04 x, and we solve this equation. So let's see, let's subtract 0.04 x to get all variables on one side. So now we got 34 plus 0.01 x equals 40. Now I'm going to subtract 34. So 0.01 x is 6. Then I'm going to divide by 0.01. Divide by 0.01, which is basically you're going to move the decimal place 2 places. So x is going to be 600. So it would take 600. So if you talk more than 600 minutes, this B is cheaper. If you talk less than 600 minutes, A is cheaper, as illustrated by these two examples. But that's the break-even point, 600. All right, and to the last learning objective, use a formula to solve a real-world application. Okay, let's look at example 3. It takes Andrew 30 minutes to drive to work in the morning. He drives home using the same route, but it takes 10 minutes longer. And he averages 10 miles per hour less than in the morning. How far does Andrew drive to work? All right, so the formula for this one we're going to need is, this is a distance, right? We're driving to work. So we have distance equals rate times time. So let's see, let's identify what we know here. It takes Andrew 30 minutes, so we have two driving to work. Well, we'll call the distance is going to be distance, we'll call it D. Let me use a lowercase d. And then his time is 30 minutes. Okay. Now we got to remember, we got to be careful about our units because this is in miles per hour, so we're going to have to convert this to hours. And his rate, he drives home using the same route, takes him 10 minutes longer. Okay, and then time, his rate, we'll just call it R for right now. Okay, and then driving home, the distance, well, it's the same. He's doing same route, so it's same D. Okay, so this is where we're going to get an equation. We're going to set these two equal to each other. His time is 10 minutes longer, so that's 40 minutes. And then his rate is 10 miles per hour or less. Okay, so now, so for distance to work, D is going, this, if we use this formula, distance to work is going to be the rate times time. And again, I want to write this in hours. So this is 30 minutes. There is 60 minutes in an hour. 60 minutes in an hour. So see, the minutes cancel and we're left with hours. 30 divided by 60 is 1/2 hour. Okay, so this is going to be, let's call this D1 and we'll call this D2. So D1 is rate, which is R, times time is 1/2. Okay, now we're going to do the same thing here. D2, let's change the 40 minutes to hours, so use the same formula I just did. 1 hour, 1 hour, 60 minutes. Minutes cancel. 40 over 60 reduces to, you can divide by 10, you get 4 over 6, and 4 over 6, and that reduces 2 over 3. And I'm going to use the same formula. So D2 is going to be the rate minus 10 times 2/3 hour. Okay? And we just established, or earlier we said we're using the same route, so D1 and D2 are equal to each other. So we're going to set these two things equal to each other. So these are equal to each other. And just going to look at just this part equals this part. So 1/2 R equals, I'm going to just move the 2/3 to the front. Just looks a little nicer. Alright, let's cancel all the fractions. So let's multiply both sides by 6. So if we multiply by 6, we get 6/2, which is 3 times R. And then 6 times 2 is 12, divided by 3 is 4. Now I don't have fractions, so that made it nice. Now I'm going to solve this equation. Distribute the 4. So 4R, and then 4 times 10 is 40. I'm going to subtract 4R from both sides. And then get -1R, or negative R, equals -40. And then divide both sides by -1. R equals 40. And these are miles per hour. Now we got to make sure we answer the question, how far does he drive to work? So we want to know D1 or D2, remember the same. So the distance to work would be D1 is going to be 40 miles per hour times 1/2 hour. 40 divided by 2 is 20. So it's 20 miles to work. Example 4, solving a perimeter problem. The perimeter of a rectangular outdoor patio is 54 feet. The length is 3 feet greater than the width. What are the dimensions of the patio? Alright, so let's start out making a drawing. We've got a rectangular patio. Okay, oops, I don't know what happened there. Okay, and then let's see. So when you do these, you should identify any formulas, you know, right? So we want the perimeter of a rectangle. So perimeter, you should know, is, for a rectangle, is twice the length plus twice the width. Okay, so if we have the length and the width, so you're going to add up the length plus the length, that gets your 2 length, and the width plus the width gets you your 2W. Alright, so we know that that is equal to, the perimeter is equal to 54 feet. So we're going to set this equal to 54, but we only want one variable. We don't want L and W. So right here, they're telling us the length is equals 3 feet greater than the width. So that's the width plus 3 more. Okay? So when we're going to use that to substitute for the the L, sorry. So then we're going to use W plus 3 for the L. So 2 times W plus 3 plus 2 times W, that's the perimeter, and we know that the perimeter is 54 feet. So you set it equal to 54, and then solve this equation. So we distribute the 2. 2 times 3 is 6. Combine our like terms. 2W and 2W is 4W. Okay, so that side's simplified. This side's just 54, so we don't have to do anything. Okay, now we want to get the W by itself, so subtract 6. So 4W is 48. And then we want to get W by itself. So now you got to divide by 4. 48 divided by 4 is 12. And then we want, what are the dimensions? So they want to know the length and the width. Well, if the width's 12 and the length is darn it. Okay, so then the length is the width, which is 12, plus the 3 more than the width. So that's 15 in their feet. And let's see, 15 plus 15 is 30, 12 and 12 is 24. So 30 plus 24 would be 54. So that checks out. So the dimensions are 15 feet by 12 feet. Okay, let's look at example 5, solving an area problem. The perimeter of a tablet of graph paper is 48 inches. The length is 6 more than the width. Find the area of the graph paper. Okay, so it's if you think of a tablet of graph paper, it's a rectangle. So something like this. So we want to make a drawing. Let's see, we know the perimeter is 48. We know the formula for a perimeter in general, the general formula, 2L plus 2W. And then they want us to find the area. And then the area formula of a rectangle is length times width. Or just LW. You don't need that X there. Just erase that. LW. Okay. Alright, so let's see. So we know perimeter is 8. So if we have, we'll call this the width and we'll call this the length. And we know the length is 6 more than the width. So 6 more than the width. Okay. So W plus 6. And then let's see. We want to find, well, we need to figure out what W is, and then we find the length and width, and then we multiply them together to get the area. All right, so let's see. We know that 2L, so back to here, perimeter is 2L, but L is W plus 6, and 2W equals 48. Okay, so now we want to solve this equation here. So this is kind of like the formulas that I know. Alright, so I'm working with this. Perimeter is 48. Perimeter is 2L plus 2W. So we knew that the width plus 6, or the length is 6 more than the width. So I'm going to put in 2 times W plus 6. Solve this equation. So 2W plus 12. Okay. Combine like terms. So 4W. And, you can subtract the 12 right now, but I'll go ahead and write it. So subtract 12. So 4W is 36. Divide by 4. W equals 9. So if W is 9, then length is 9 plus 6, which is 15. So then our area is length times width. So it would be 15 times 9. And what were the units? These are inches. inches, inches, inches. So this is inches times inches, which is, let's see, 45, 135 square inches. You can write it like that, or you can write it like inches with a square. Either way. Okay, 135 square inches. Let's look at example 6. Find the dimensions of a shipping box given the length is twice the width and the height is 8 inches. And the volume is 1,600 or 1,600 cubic inches. All right, so a box, the volume for a box, so is length times width times height. You should use dots, not times. But anyway, let's see, what else do we know here? So we got, so the length, we'll call this the length here. So that's our length. We'll call this the height. And we'll call this the width. Okay. So basically, this edge, that's the width. And then this will be our length. And then our height. Okay, so length, width, and height. Let's see, what are we given here? Find the dimension. The length is twice the width. Length is twice the width. The height is just straight given to us as 8. Okay, so now let's plug in the volume. 1,600 cubic inches. The length is 2W times W times the height, which is 8. So we simplify that. 2 times 8 is 16. W squared. We're going to divide by 16. So it's 100. And then W squared is 100. So we square root both sides. We haven't really talked about solving a quadratic equation yet, but this is pretty simple. Right, you're going to square root both sides. So W is 10. Right? And technically, right, the square root of W squared is the absolute value, so that would give you plus or minus. But since this is involving a length or width, we don't want a negative width, so we just throw out the negative one. Okay, so the width's 10. So if the width's 10, so that equals 10. Twice the width would be 2 times 10. 2 times 10, which is 20. And what were the units? Inches. And then that's 8. So the box is 20 inches long, 10 inches wide, and 8 inches high. All right, and that brings us to the end of today's lesson. And I'll see you next time.